Alright, so what we're looking at now is that we're looking at the second half of problems. So we're going to be looking at geometric sequences and deferred annuities and installment loans. So we're going to be looking at those three. We're going to be looking at three separate problems involving those three topics. So the first one we're going to be going over is the geometric sequences. Alright, so the first problem is number 53. And the first two terms of a geometric sequence, g sub 0 is 3072, and the second one, or g sub 1, is 2304. And the question is find the common ratio, find g sub 4, and find the explicit formula for g sub n. To find the common ratio of a geometric sequence, what you're going to do is you're going to take the previous number, so the first number, and divide it by the second number. No, scratch that. Do it the other way around. You take the second number, and you divide it by the first number. So what we're going to do is we're going to take the second number, 2304, and we're going to divide it by 3075. And when you divide that, you end up getting a nice fraction of 3/4. And that is your common ratio. So you divide the second number by the first number, and you get your common ratio. Now, to find the fourth number in the sequence, one way of doing this is just to multiply it going down, or you could use the geometric sequence formula. The geometric sequence formula, g sub n, is equal to g sub 0 times the ratio to the nth. Okay. So when we plug in our numbers, g sub 0 is 3072. The ratio is 3/4, and we're going to take it to the fourth power because we want to find the fourth one. Now when we multiply that through, so we go 3/4 to the fourth, and then we multiply 3072 into that, we end up getting a nice integer of 972. And that would be the fourth number in this sequence by taking 3/4 of the numbers and going down. Now it wants to know the explicit formula, which is just the general formula. The one that's going to have a variable in it, in this case, is going to be n. What you're going to do is you're going to have g sub n is equal to, and you plug in g sub 0, 3072. You plug in the ratio, 3/4. And then where the n goes would be the power. So it would be to the nth. And that would be your explicit. And that's it for that one. So geometric sequences are pretty easy. Now let's go to a little more complex stuff that's got a little bit more algebra into it. Alright, so the first one, Layla, like the song, plans to send her daughter to Tasmania State University in 12 years. Okay. Her goal is to create a college trust fund account worth $150,000 in 12 years. She plans to make weekly deposits into a trust fund that earns 4.68% annual interest compounded weekly. How much would she have to deposit each week to make this trust fund happen? Okay. So what we're going to have to do is we're going to have to use the deferred annuity formula. And again, remember the deferred annuity formula is F, or the final, is equal to the principal, or how much you deposit, times 1 plus lowercase p. Okay, remember that is the rate over the number of times per month, which in this case it would be 0.0468 divided by, it's weekly, so it's 52. And then we're going to multiply that by 1 plus lowercase p to the t minus 1 all over p, lowercase p. So when we want to plug all these numbers in, we're going to plug in 150 because that's what we want to have at the end. Capital P is what we're searching for. When we plug in 0.0468 and divide it by 52, since it's weekly, we end up getting a number close to 0.0009. So we add 1 to that and we get 1.0009. And then in our brackets, we're going to have 1.0009 to the t would be 52 times 12, which comes up with about 624. Subtract that by 1. Put that all over 0.0009. And then when we start calculating this down and getting it smaller and smaller and smaller and smaller and smaller and smaller and smaller, we end up getting $837.456361 p, and that equals 150,000. So then you divide it through. Okay. Using algebra, you know, if it's multiplied, then you divide it. So we end up getting P is equal to $179.11. So Layla would have to deposit that much a week for 12 years straight to be able to make sure she has enough to send her daughter to Tasmanian State University. Okay. So again, a lot of these are plugging it in, finding where the variable is, and then using algebra to bring it over. Okay. All right. Now the last one. The installment loans. So the Simpsons, you know, this lovely family that's been around for 26 years now, longer than I've been alive, is planning on purchasing a new home. To do so, they need to take out a 30-year home mortgage for a loan of $160,000 at Middletown. What is this? They don't live in Middletown. They live in Springfield Bank. All right. The interest rates that Springfield Bank gives for a 30-year mortgage is around 5.75%. Okay, compounded monthly, of course. And the question is asking, how much do they pay per month, and how much interest will be gained throughout the 30-year loan, the life of the entire loan. Okay. So the first thing we have to do is find out how much they're paying per month. All right. So I'm going to take this and I'm going to crinkle it up and throw it onto the next clean slate, and we're going to be using our installment loan formula, which, remember, the installment loan formula, when we plug everything in, we're going to have 160,000 is equal to the monthly payment times 1 over the percentage, which would be 1.00479. All right, and again, that's taken from, since it's monthly, you take the percentage 0.0575 divided by 12, and that's how we're getting this number. And that's being multiplied by 1 over 1.00479 to the t, which would be 12 times 30, subtracting that from 1, dividing it by 1 over 1.00479, subtracting that by 1. And now after that, we're going to start simplifying this. So again, this stays the same, 1.00479. This becomes negative 0.82098 all over negative 0.004767. And then after that, we're going to multiply those together and then get the f by itself. And again, this is still equal to 160,000. So again, using algebra, you want to multiply this together and then move it to the other side. And then move it to the other side by dividing it, of course. And we get f is equal to, or their monthly payment will be equal to, about $933.49 approximately. Now again, depending on how far you go with some of your estimates, you might get a little bit different, off by a couple cents, maybe even a whole dollar. Right? But you're going to have a little bit of change there. Now that's for A. That's what A wanted. Now B wants to know how much interest was earned. So we take their monthly payment. 933.49, and multiply it by how many payments they made. Well, they made 12 a year for 30 years. So you take the payment, multiply it by 12, multiply it by 30, and that tells you that they paid a grand total of 056.4. So they paid $336,000, $56.40. So the interest earned over the life of the loan would be this, what we just calculated, and subtracting out the original amount. And that gets us a grand total of 176,056.40. So as you see, they paid more from the interest than they would have for the original loan. And that just is frustrating and everything. All right. So as you see, the interest gains really fast. All right.